Hi, I am Sriranjani Ramkumar from Product Marketing team here at MathWorks, and welcome to the video on getting started with the digital input-output on the Renesas RH850 Microcontroller. In this video, let's focus on the digital channel read block in Simulink and show you how to read the status of the switch and change the LED blinking rate each time when a rising edge is detected. Through this demo, user will have the clear understanding of scheduling and configurations to enable multitasking along with how to properly configure the digital channel read block. Let's begin with the hardware connection. Connect the RH850 starter kit to the Renesas E2 emulator. Power the board using 12-volt adapter. Connect the E2 emulator to the host computer where MATLAB is installed using an USB cable. With the hardware connection set up, I have the Simulink model opened for this example, where I have a digital channel read block configured to read the status of the switch SW20. Double-click to open the block parameter. The channel identifier parameter is used to reference the corresponding port and pin configuration. For this example, the onboard switch SW20 is connected to port group 2 and pin 3, which we will be configuring in the DaVinci. And then use the same identifier name in the Simulink so that the block is mapped correctly to the corresponding configuration in DaVinci. You can also configure the block later once you have the CDF included so that you need not remember the identifier in advance. Simply use the Get DIO channel option to retrieve the list of available channel identifiers from the imported CDF and select the appropriate one for this block. Let's come back to this again once we have the CDF included. Now, this block is connected to the function trigger subsystem. Whenever a rising edge is detected, the following switch sequence is used to control the multi-port switch. The multi-port switch is connected to 3 pulse generator block that generates pulse at 100 millisecond, 500 millisecond and 1000 milliseconds. As the output of the switch is connected to the digital channel write block, which is configured for the channel identifier corresponding to the user LED configuration in DaVinci, the LED toggles at these rates. To understand how multitasking functions are scheduled, let's turn on the color coding and look into the timing legend. Scheduling is based on the base rate, that is the fastest loop, calculated as the greatest common divisor of all blocks sample time. Blocks that run at the base rate are shown in red. Tasks that run slower are subrates, which are derived from base rate, shown here in green and blue color. In this example, the tasks at the base rate runs every 0.1 second, while the subrate 1 tasks executes at every 0.5 seconds and the subrate 2 tasks executes every 1 second. Each subrate aligns with the clean multiples of the base rate, ensuring hard real-time requirements are met. Now that we understood how multitasking scheduling operates, let's open the Simulink configuration parameter to enable multitasking so that the scheduling is automatically handled during the code generation and the model is properly configured for your hardware. Press Ctrl E to open the configuration parameters. Then navigate to the solver settings and enable treat each discrete rate as a separate task. Next, in the hardware implementation tab, select the hardware board and the device series, as this sets up the model for RH850 microcontroller so that the generated code is tailored for the hardware. To set up the peripherals of RH850, let me import the default CDF that's provided by the HSP for RH850 U2A. The default CDF has DIO, GPT, MCU and port modules configured to initialize the board with necessary clock settings. By clicking on Import and selecting the CDF, that is this ARXML file, you'd be able to see the default CDF imported into the working directory. And the path to the working directory is added here in the configuration parameters. To configure the DIO channel read and write, let me walk you through the DaVinci configurator settings. You can use any of the MCAL configurator tool to configure the MCAL peripherals. In this case, I am using the DaVinci configurator. Create a new ECE project in the DaVinci configurator and import the default CDF from the MATLAB working directory. Open the project settings. Under modules, you'd be able to see the default modules are added to the project. You can add more modules if required, but these 4 modules are mandatory to build the model for code generation. Now, go to the basic editor. To configure the switch SW20, go to the corresponding port pin, which is P2 of 3. Hence, go to port group 2 and select port pin 3. Set the pin direction to input and make sure the input buffer control is enabled. Having done the port configuration, Now let's do the DIO configuration for the switch. Go to DIO ports and create a new port container. Provide the container name and select the port group to bits 0 to 15. Now create a channel container under port container and select bit position 3. Now to configure for the user LED, go to the corresponding port and pin number, which is P6 of 6. So go to port group 6 and select port pin 6. Set the pin direction to output mode. To configure the channel for the corresponding port, add a DIO port container if needed. By default, the DIO port is added and configured for port group 6, under which you can configure the channel 0 to 15. Now to configure a channel, add a channel container. By default, a DIO channel container is added and configured for channel bit position 6. Thus, we have configured the channel 6 of port 6 as an output pin, enabling it to drive the user LED. Once that's done, I'll export the CDF. Let me save it as multitasking.arxml in the same working directory. Switch back to the configuration parameter in Simulink environment. Browse to locate the exported CDF to include it back into your model. Now, to view the generated code, go to the code generation and under report, enable create code generation report and open report automatically. Click on apply and OK. With the hardware boot selected in the configuration parameter, a new hardware tab appears in the Simulink displaying the selected hardware boot. With everything configured, before we move into deployment, let's quickly look into the block parameters of Digital Channel Read block and see the Get DIO channel functionality. By clicking on Get DIO channel, it displays the list of DIO channels available from the DaVinci configuration. Since I have already configured the DIO channel for the switch SW20, I can select it directly from this list instead of typing the identifier manually. In a similar way, the Get DIO channel option in the Digital Channel Read blocks can be used as well. DIO channel 001 is configured for the user LED. I can select the identifier directly from this list and add it to the block parameter. Thus, by using Get DIO channel, it ensures that only identifiers configured in the DaVinci are selected, reducing the chance of using a non-configured identifier. With everything configured, click on Build, Deploy and Start. This builds the model, generates code and deploy your model onto the microcontroller, allowing you to see the LED blinking at multi-reads as you press and release the switch each time. Before we wrap up, let's take a closer look into the generated C code and understand the scheduling part. Here is the CodeGen report, which opens automatically after successful build. The C code for the model is generated under the name modelname.c and the function modelname_step0 corresponds to the task that runs at the base rate. And as I mentioned earlier, this function runs at the highest frequency defined in the model. The function modelname_step1 or step2 are the tasks that runs at the subrate. The scheduler triggers these tasks at the designated interval, coordinating them with the base rate task. This structure allows the controller to efficiently execute multitasking, ensuring each part of the algorithm runs at the right time. And that's it. You have learned how to set up the digital channel read block for Renesas RH850 microcontroller and understood a bit about scheduling. I hope this video is helpful and thanks for watching this video.